Good morning, everybody. I'm Mr. Hartzler, and I wanted to talk to you in this video a little bit about trig again. And this time in particular, we're talking about my section 3 for my students, and we're talking about trig functions and real numbers. So I have to keep checking my notes on this kind of stuff. But it's not terribly hard. Sometimes it can be a little bit weird to think about the first time that my students really experience trig. But it's not challenging. It just takes a little bit of maybe thinking about and practice, definitely some practice. All right, so let's get started here. I'm gonna share my screen with you. All right, let me make sure this is full screen. All right, so the first thing I want us to work on is finding sine, cosine, and tangent of a particular angle. So let's look at 90 degrees first. So sine of 90 degrees. For this one, I'm going to start by referencing not a triangle, but the unit circle. So let me draw that over here. So my unit circle, a crappy circle, but you get the idea. 90 degrees, where's that at on this graph? So it's up here. We've talked that sine and cosine end up making up our coordinate points, right? And the nice thing about this is it happens alphabetically. So cosine theta first, and then sine theta, just like if they were in alphabetical order. So at this spot, what is my coordinate point? Well, it's going to be 0, 1, because I'm left and right 0, and I'm up 1. So which one of those is my sine? Well, that is the second one. So sine of 90 is 1. Cosine of 90 degrees, it's going to be the x part of that coordinate, so it's going to be 0. Tangent of 90. We've talked before that we really only need to memorize sine and cosine, and sometimes we can use our unit circle as our reference. So and if you haven't seen a completed unit circle, I haven't done a completed one, but you could do a quick Google image search for that and find that information. Very helpful. I recommend you look at it a couple of times, actually. Tangent is the same as sine 90 over cosine 90. So what is sine of 90? Sine of 90 is 1. Cosine 90 is 0. Okay, so I have 1 divided by 0. That's that common, I have 1 cookie and I have to put it in 0 groups, and that can't happen unless the cookie explodes into a billion pieces, and then, I mean, the answer would be a billion, so it would be split into 0 pieces. So anyway, you see the weird conundrum there. I think even Alexa talks about that in a funny way. So this is undefined, and I'm going to write it as undefined. Okay, it is undefined or indeterminate if you want to be like that. It's not, sometimes it's written does not exist, but I would write it as undefined. And actually in some calculus books, I've also seen it written as infinity, but that's more looking at how things approach things. So right now we're going to leave it as undefined. All right. So that is for 90 degrees. So I'm going to just very quickly bring up down here. This would be 270 degrees. 270 degrees, or what would that be? Not, so pi plus a quarter pi, so 3 halves pi. That's the same as the 270 degrees. So this one would be 0, -1. Should have done this first. Over here at pi radians, I'm at -1, 0, and at 0 or 360, I am at 1, 0. So cosine at 0 is 1. Cosine 0 is 1. And that's then sine 0 is 0. And then over here, cosine of 180 degrees is 1. And sine of 180 degrees is 0. Okay, just so we can kind of see how all of that's shaping up together. Okay, let's save this and let's clear it all up. We're going to find the same thing again, except now for 135 degrees. That is going to be the same as our reference angle over here. I'm going to change colors up as 45 degrees. And we are also, if we convert this into radians, right, I can multiply it by pi over 180, or I could simplify because I know it's a 45-degree angle reference. So I'm going to be over 4. and I am a fourth short of a full pi. So it's 3/4 pi. So I know I kind of talked about that weird, but you'll get more practice. If you still have some issues, do some converting. But what I really did was all the way over to this line is pi radians, and I am pi over 4 short of that. So I subtracted that from the full pi. Okay, so I'm over here. I'm going to make my little reference triangle. Cool. Always reference to my x-axis. So all students talk constantly. So that tells me which one's positive, which one's negative. So I know sine is going to be positive here. Sine of 135 is the exact same triangle as sine of 45, and I know it's going to be positive because I've checked using my little circle here. And sine 45, I talked to you in one of our first videos that is going to be one of our memorized values. So anything comes from a 45, 45, 90 triangle or a 30, 60, 90 triangle is memorized. Go back and look at that video and you can check that out. So that's going to be a square root of 2 over 2. I do not want any kind of decimal value for any angle that is a 30, 45, 60, or 90 degree angle, okay? Or any variation thereof, like this one's 135, well, it's a reference angle of 45. All right, so now let's do cosine. So cosine 135 is, again, it's the same triangle as a cosine 45, right? We've talked about this before. If it's over here and it's a 45-degree angle, it's the exact same dimensions as this other triangle over here. But I have to account for whether the coordinate points on this end right here, if it's a positive number or a negative number. My x-axis, that's going to be a negative number, right? I'd be like to the right 3, we'll say, and up, so a positive number for my sine. Okay, so cosine is in fact going to be negative. And that came from, again, sine is the only one that's positive there. Everything else is negative. So this is going to be a negative square root of 2 over 2. Again, a memorized value. And we'll do tangent 135. Forgot to switch colors. My bad. Again, it's going to be negative, but it's going to be the same triangle as a 45-degree triangle. And 45 degrees for tangent is 1, and it's negative because of the quadrant I'm in. And again, that could come from these two numbers, right? Sine divided by cosine. They're the same things, but one is negative, so my answer is negative here. Okay, let us do one more, but let's do it in radians. So 3 pi over 4. Sine of 3 pi over 4. Well, I should actually draw this picture first. All students talk constantly. Oh, we're actually right here. Boom. With a reference angle of pi over 4, which is equal to 45 degrees. Fun fact, that's exactly the same as the last one. Sweet. All right, I'm just going to clear that. We don't need to do that anymore. We just did that. So go backwards and look at it again. All right, so now let's find the coordinate of our terminal side. So let's say we're at 2 pi over 3. That is right about here. So remember, over here is pi. Oh. This one would be pi over 3. And there's an to here. And then here is another pi over 3. And then that is our third pi over 3 to get us to a full pi. All right, so let's undo a bunch of those little lines. There we go. Still undoing. Yep. There we go. All right. So we're here. What quadrant are we in, folks? Yep, we are in the second quadrant. And since we know all students talk constantly, we know sine's going to be positive there. So for this coordinate, right, which we could also guess just because of our math experience, the x coordinate is going to be negative and the y coordinate is going to be positive. So what is my reference angle? Well, it's going to be, if this part is 2 pi over 3, this other chunk is going to be pi over 3. That's my reference angle. If you're still having some issues with this and you need it to be in degrees to really remember some stuff, then do the conversion. But I'm going to tell you right now, that's a 60-degree angle. Anytime that the fraction's reduced, right? So if this were a 6 pi over 2, well, that reduces further, so that doesn't play into this. But if this is already simplified as much as it can, which it is, 1 over 3 pi, then that 3 on the bottom means it's going to be a 60-degree angle. If it were something over 4, then its reference is going to be a 45. If it was something over a 6, then its reference is going to be something like the 30-degree, right? So it could be 30, could be all the way over to 150, because that's also a 30-degree triangle. See what I mean? All right, so we're looking at this as our reference. So cosine, we'll do that first because that's our x-coordinate of pi over 3, or 60 degrees. That is 1/2, again, memorized value. And then sine of pi over 3 is square root of 3 over 2. Again, memorized value. So my coordinate point here would be 1/2, but remember it's negative because I'm in the second quadrant. Cosine's negative there. And my sine part. Cool, hopefully this was helpful, but if not, we're gonna do another one, so let's try that. So my next one is 315 degrees. Boop. If that full thing is 315 degrees, what's my leftover piece here? 45, right? You guessed it, good job. And remember, that's the same as a pi over 4, so this whole other thing is 2 pi minus pi over 4, and that is, I'll get a common denominator, right? So I multiply this side by 4 over 4, so that's 8 pi over 4 minus pi over 4 gets me 7 pi over 4. All right. So again, I'm doing all of this to show you what I'm doing in my head. So I think it's important for all of you to see how I think about it, because, I mean, if I'm still showing this work, you guys probably should still be showing this work. All right, so I'm erasing some of that now. You can go backwards in the video, so I don't need to keep it here. All right, so I am in all students talk constantly. So I'm in the third quadrant. Cosine is the only one that's positive. So this coordinate point, and my x is going to be positive, and my sine value is going to be negative. Cosine of 7 pi over 4, which, remember, it's a simplified fraction. 7 over 4 is simplified. And a 4 in the denominator means it's a 45-degree reference. My 45-degree angle for cosine is square root of 2 over 2. Sine is going to be similar, except that it has to be negative because I'm in the fourth quadrant, right? So my y value would be negative. So it's a great way of thinking about it too, just straight up, what's my x coordinate going to be? What's my y coordinate going to be? Positive or negative? So this coordinate, square root of 2 over 2, comma, negative square root of 2 over 2. Not too shabby, right? It's not too terrible. I'm actually not going to do any more with that one. So we're going to move on. So what does sine theta equal if it is given to me that cosine theta equals negative 6 over 10? And I know I'm in quadrant 2. So I'm just going to draw some random angle there. I'm here. And I know my x coordinate is negative 6 over 10. I don't know my y coordinate. Well, folks, let us build a triangle, right? Because I know cosine theta equals right? So adjacent over my hypotenuse side. So this is adjacent right here, or next to my angle. And hypotenuse is, I mean, obviously the longest side. So I know cosine theta equals negative 6 over 10. Well, remember, we're looking at side lengths now, not necessarily location. So the negative part doesn't matter. But I know that that's going to equal adjacent over hypotenuse. Awesome. I know my adjacent side. I know my hypotenuse side right now. So boom. That's a 6. That's a 10. Let's do Pythagorean theorem to find the rest of it, right? We could also scale this down because it simplifies, right? So that's a 5 over a 3. So I scaled down by a factor of 2. Pythagorean theorem would say my opposite side squared plus 3 squared equals 25 squared, not to the 6th. So this is a 9. Subtract the 9 from both sides. Oh, and that's just a 5 squared, which is 25. I was getting ahead of myself there. All right, so 25 minus the 9 is 16, right? So opposite side squared equals 16. What's my opposite side? Yeah, you're right, 16, right? Because I square root both of these. So I know that my adjacent is 6. I know that my hypotenuse is 10. And I know my opposite, we found here to be 4. So that's, I'm going to change colors so you can see where I'm at here. So on this little triangle, it's a 4. But remember, I cut it in half, so I have to double it back up again. So this side would be an 8. But it's all proportional. So that part actually doesn't matter. So I could use either one of these two triangles. So I'm going to stick to my simplified one. And I'm going to say that my, for that one, my adjacent was 3. My hypotenuse was 5. And my opposite was 2. So now they were asking for sine. Well, sine is going to be soch, opposite over hypotenuse, so 2 over 5. And just to show you up here, right, we found that this opposite side was going to be 8 if we got everything back to the right size. And so on that one, it would be 8 over 10, which again simplifies to 2 over 5? No. 4 over 5. 4 over 5. My bad. I wrote the wrong number here. Opposite should be 4. I wrote this number instead of the actual side length number. That was my bad. My fault. All right. So I know we were kind of all over the place, but hopefully that helps a little bit. So you can always watch that again. All right. Let's clear all of this and let us look at what tangent of 11 pi over 6 is. So first, what's my reference angle going to be? The angle is simplified. So this here is going to be a 30-degree reference angle. But what quadrant am I in? Well, I'm really close to 2 pi. So I'm actually, well, I went a little too far. And it erases the whole line. So let's do that again. Right to there. So my reference angle is going to be 30 degrees because my denominator was a 6. And my full thing here is 11 pi over 6 or 330 degrees. Okay, so remember that coordinate point or the tangent of this comes from sine over cosine. And we're looking at of a 30-degree angle. These again are memorized. So what's sine of 30? 1/2. Cosine of 30 is square root of 3 over 2. So this is where we're going to do a little bit of algebra 1 stuff. So we're going to do what my students like to refer to as keep, change, flip. So I keep the top the same. I change my symbol in the middle, and then I flip, or I use the reciprocal of my denominator. So I keep the numerator the same, change my division to multiplication, and I use the reciprocal of my denominator. So I kept, I changed, I flipped. I cross reduce because I'm cool like that. 1 over square root of 3. But we have to rationalize because some person said it was worthwhile. I don't know. So tangent of 11 pi over 6 is square root of 3 over 3. But we did not check to see if it's going to be positive or negative. So in this location, right, the x coordinate is going to be positive. The y coordinate is negative. So my denominator is positive. My numerator is negative. My overall answer is negative. I can also do that little mnemonic device I taught you, right? All students talk constantly. So cosine here means that tangent is going to be negative. All right, I'm talking kind of fast, but you can always slow this video down. So I hope that was helpful. Let us do another one similar to that, okay? I want us to do now tangent of 750 degrees, but let's do it negative. right? Because that's just fun. Let's just make it more unique. In the words of Emerson, let's do a harder one, right? So it's negative. That means I'm going this direction. Remember, 360 degrees is back to where I started. What's another 360 degrees, right? Let's actually do this 750 minus 360. So the zeros, 0, 75 minus 36. So let's change that to a 6 and change that to 150 minus 60 is 90. And then 600 minus 300 is 3. Okay, so I do have another full circle in there. And then I have another 30 degrees. Okay, so again, there's inside of this 750. Let me erase a little bit of this. Okay. So inside this 750, right, a negative 750 is composed of a negative 360 and another negative 360 and then a negative 30, right? All of those together combine to get me the negative 750. If you don't believe me, grab a calculator, do it, right? So this is one rotation. This is one rotation. And then an extra 30-degree booger. That's this part right here, right? That filled in part of the pie. So 2 full loops. You can see that by my 2 circles. And then the 30 degrees. I also want to make sure all of my students out there are aware I'm actually doing this problem, right? I've never done this problem before. So I'm drawing this stuff. I know a lot of you, for some reason, are trying to conserve paper, right? You're super green freaks, but please use up a little bit more paper and ink or lead and write this stuff down. Draw these pictures. It's so incredibly helpful. You really need to do that. So this reference angle here is 30 degrees. So what is tangent of 30 degrees now, right? I mean, same triangle if we built it over here, all right, like that, or if we built it just above it, above the x-axis, right? It's the same shape triangle if I could draw straight. But I have to keep in mind that it's down in the 4th quadrant. So all students talk constantly. Cosine's positive, so my tangent value is going to be negative there. I've told you before, tangent 30 is square root of 3 over 3. You could also do that by doing sine 30 divided by cosine 30. And we actually did that very recently. So cool. Calling this one done. Clear. Oh, cleared it all. Okay. Now it's my secant, cosecant, and cotangent. So I'm actually just going to do this for one angle. I'm going to do it for 120 degrees. Mostly because I'm supposed to be on Instagram Live right now doing one of my videos. So here we are. Secant of 120 degrees. I'm going to draw that picture. So it's over here. It's a 60-degree reference angle, okay, because that's what it takes to get me down to my x-axis here. And all students, so sine's positive there, everything else is negative. So that means that this secant is the same as secant of 60 degrees. And remember, secant is a reciprocal function for cotangent. Or sorry, for cosine. For cosine of 60 degrees. But remember, we were originally 120. We're in the 2nd quadrant, so I know cosine is going to be negative here. So I had to throw that negative out. So 1 over negative, and what is cosine 60? This is a memorized value, and it's actually 1/2. Keep, change, flip. So 1 times negative 2 over 1 is just a straight up negative 2, folks. And let's do cosecant. Cosecant, CSC, yep, of 120. Well, that's the same as 1 over sine of 120. We talked a second ago, sine's positive there, so this is cool. So let's do regular sine of 60 then. Sine 60 is square root of 3 over 2. Ooh, forgot to put it over 1. Keep, change, flip. So I have now 2 square root of 3 by similar stuff to what I did up here, okay? And now I need to rationalize again. So square root of 3, square root of 3. I know I'm going kind of quick, but you guys can always kind of double check some of these things and work these out through yourself, right? You shouldn't just be relying on my stuff. You should be working through the problem yourself and trying to fill in the gaps with what I'm showing you. So this is after rationalizing for cosecant. And then let's look at cotangent of 120. So that's 1 over tangent 120. I could also think about this, right? So 1 over tangent is sine over cosine. But then that is going to be the same if I keep change and flip as cosine 120 over sine 120, right? The reciprocal functions. So I'm going to divide these other two things, and we'll have, which one was it? Sine, okay, sorry, cosine of 120, or, right, this 60-degree angle is a negative 1/2. So I have negative 1/2 over sine, which was square root of 3 over 2. Fun thing here, these halves, since they're both in the denominators on the numerator and denominator, it's weird there, they cancel. And I'm left with a negative 1 over square root of 3. Rationalizing gives me a negative square root of 3 over a normal 3. Boom, there it is. All right, so I hope that part was helpful. Let's, I need to get through one more real quick. And cotangent of 180 degrees equals 0. That's a statement made by somebody. We want to decide, is this person right? So first, I'm going to change this to, instead of cotangent, I like tangent. So 0 is like a 0 over 1, right? I can divide anything by 1, still the same thing. So that means tangent 180, does it equal, this would be now 1 over 0, right? Because they're reciprocal functions of each other. So if cotangent equals 0 over 1, tangent should equal 1 over 0. Well, where's 180 at? It's here. And I know that coordinate point because my unit circle is a radius of 1. So over here, 1 is negative 1, and my sine is 0. We also talked about that earlier in this video. So tangent is going to be the same as sine over cosine. And my question still is, does that equal 1 over 0? Sine at that value equals 0. Cosine at that value equals negative 1. So does that equal 1 over 0? No, it does not. So I can't remember what they said the person's name was. It was a guy's name. So we'll say Alex is wrong. I think it was a Latin name, but Alejandro, Alexandra, I don't know. Anyway, the person was wrong. So we're going to say now that this section is done, I'm going to clear all of these things. I'm going to stop sharing. All right, so it's back to just me. Thank you, everybody, for watching. Please click that like button down below if this was helpful. It really does help me to know, was the video good, was it bad? And I can look at that to figure out what I need to change in future videos. Subscribe by clicking that subscribe button down below. And if you click that little bell thing, I can't do a bell with my hands, I don't know why I tried. But if you click that bell, then you'll get notifications about when I make new videos. And I've been home a lot lately, so I've been making a bunch of them. So please click that bell and you can see when my new videos come out. Again, if you have any comments, if you found an error in something I did, or if you have a question, please put that down in the comments. If you're one of my students, shoot me an email. That's incredibly helpful. Incredibly helpful for me to figure out if you need help with something, what you need help with, and maybe I need to make a new video for this. Maybe I just need to talk to you one-on-one or in like a small group section, like in Math Lab, and we can try and answer some of these questions for you. So again, if it was helpful, click that like button, and I appreciate you watching. Share this with anybody else that it might be helpful for, right? So a lot of me and the other Algebra 2 classes are at the same level. So if you want to share it with one of your friends who's having issues, please do that. And I appreciate all of you. Have a safe day and do things carefully with enthusiasm. Bye.